Hello everyone. In this question, it is given that if the equations ax square plus 2bx plus c equal to 0 and ax square plus 2cx plus b equal to 0, where a is not equal to 0 and b and c are unequal, have one common root, then we are to find the equation that is formed using the two uncommon roots. Okay, so first of all, we are given these two equations, ax square plus 2bx plus c equal to 0 and ax square plus 2cx plus b equal to 0. Okay, and we are given that a not equal to 0, otherwise it won't be a quadratic, and b and c are not same. Okay, so these two are different equations. Okay, so we are given that these two have one common root and we have to form the equation using the two uncommon roots. Okay, so if I say that, let's say this equation, okay, this has roots alpha comma beta, and this second equation, this will have roots, there is a single common root, right? So alpha, let's say alpha is the common root, the other root will be alpha comma gamma. Okay, so first of all, if we start now, since alpha is the common root, okay, so alpha will satisfy both equations, right? So the first equation will be a alpha square plus 2b alpha plus c equal to 0, and the second equation will be a alpha square plus 2c alpha plus b equal to 0, right? Let's say this is 1 and this is equation 2. Okay, if I subtract equation 2 from equation 1, that is 1 minus 2. Okay, we get this a alpha square will get cancelled out, right? So this will become 2b alpha plus c minus 2c alpha plus b inside the bracket. So if I take the 2 alpha common, this will become b minus c plus c minus b equal to 0. So if I take this c minus b to the other side, this will become 2 alpha times b minus c will be equal to b minus c. So this implies 2 alpha is b minus c upon b minus c. So this is 1. So this implies alpha, which is the common root, this is equal to half, right? If 2 alpha is equal to 1, that means alpha is equal to half, right? So we got the common root. The common root is equal to half. Okay, so this alpha can be replaced with half now. Okay, so now again, if we look at the product of the roots, if we look at the sum and product of the roots of this, okay, this will give a x square plus 2bx plus c equal to 0. Roots are half comma beta. Okay, so therefore half plus beta will be equal to minus 2b upon a, and the product will be beta upon 2. Beta upon 2 will be c upon a, and for the other equation, ax square plus 2cx plus b, the roots are now half comma gamma. So the sum of roots will be half plus gamma is minus 2c upon a, and the product of the roots will be gamma upon 2, which is equal to b upon a. Okay, so these are the few conditions we have. Also in the original equation, if we put half there, okay, also the equation is ax square, right? So since half is a root, I can substitute half in place of x, right? So this will become a times half square plus, let's say I'm using this first equation, okay, this ax square plus 2bx, I'm using this equation, times half plus c equal to 0. So this will give a upon 4 plus this 2 times half will cancel out plus b plus c is equal to 0. So this is a condition we have. Okay, I think this is equation number 3. Okay, let's see if we can use this equation or not later on. From this beta upon 2, if we try to find the value of beta will be 2c upon a. Okay, I am not using this other equation because this is half plus beta and this is a bit more clumsy. Similarly here also I am using this product relation here. So from here on cross multiplying, we get beta equal to 2c upon a, and from this one we get gamma equal to 2b upon a. Okay, so therefore equation with roots, the uncommon roots beta and gamma, is x square minus beta plus gamma times x plus beta gamma is equal to 0. Okay, x square minus, now what is beta? Beta is 2c upon a and gamma is 2b upon a. Okay, so 2c upon a plus 2b upon a times x times the product, that is 2c upon a times 2b upon a is equal to 0. So this further on simplification gives, this becomes 2c plus 2b upon a times x, and this becomes 4bc upon a square. Okay, now we have this relation from equation 3, a upon 4 plus b plus c equal to 0. Okay, so if I use this equation, okay, if I'm using this equation, I have b plus c here, right? 2b plus 2c. Okay, so b plus c is equal to minus a upon 4. So if I multiply then both sides by 2, this will become 2b plus 2c will be minus 2a upon 4, which becomes minus a upon 2, right? So I have 2b plus 2c upon a, so I will divide both sides by a. So this will become 2b plus 2c upon a. This will be equal to, the a will cancel out, this will become minus half. Okay, so I can use this value here. Okay, so this will become x square minus half times x plus 4bc upon a square is equal to 0. So this now becomes x square plus x upon 2 plus 4bc upon a square is equal to 0. So on taking the LCM, this will become 2a square x square plus a square x plus the 2 will come, so this will become 8bc equal to 0. Okay, so if I take a square x common from these first two terms, okay, this will become a square x times 2x plus 1 plus 8bc equal to 0. So this is the final required answer. Okay, this is the equation that is formed. Okay, you can keep it in this step also. It is correct if you keep it in this form, but I have taken this a square x common from the first two terms. Okay, so this is the final answer. Okay, you have to use a few slight tricks, that is you have to find this condition a upon 4, and once you find this condition after getting the common root, it is very easy. Okay, so if you have any doubt, you can state it in the comments. Okay, I will respond to you. Otherwise, this is done. Okay, thank you.